Alright guys, welcome back to another set of video notes. This is for lesson 9.6. We're going to look at this situation of should Rockford switch to bottled water. So the Wolverine Worldwide, which is a shoe company in Rockford, Michigan, improperly disposed of chemicals which have leaked into the groundwater. The state of Michigan says that if more than 7% of households in a city exceed the safe limit, the city needs to switch to bottled water. Now we're going to put smiley faces for correct decisions and frowny faces for incorrect decisions here. And we're talking about what that means. So when we look at this here, just in general, like this doesn't even have to necessarily be in this situation. If we think about the fact when we reject our null, that being a decision, what it means is we have convincing evidence of our alternative. Which, see here though, this is actual truth versus decision. So if the actual truth is that the alternative is true, and we make the decision to reject the null, we did good. We did the right thing here. It lines up. Likewise, if the actual truth is that our null is true and we fail to reject the null, that's a good thing as well, because we went through and we said, hey, we failed to reject the null. We don't have convincing evidence of our alternative. We find out that the null is true. We did a good thing. Where we get into trouble, what if we reject the null, but the null is actually true? That makes us sad. This is what we call a type 1 error. And we're going to see that in action here in a minute. Hopefully you can also see if the alternative is true, but we failed to reject the null, that's also not a good thing. We'll see like real world examples here. But this is called a type 2 error. So let's go through and look at like what that actually looks like for us. So a concerned citizen takes a random sample of 100 households in Rockford and finds that 12 have unsafe water. Does this result give convincing statistical evidence that Rockford should switch to bottled water? Now, state appropriate hypotheses for performing a significance test with alpha 0.05. Back up here, we said that more than 7%. So the water is safe if we are at 7%. Also, if we're less than 7%, but we don't have to worry about that because if we're at 7%, we're good. The water is unsafe if there's more than 7% of households. Remember, we always want to list what P is. So these are our null and our alternative hypotheses. You can also see we do have not convincing, but some statistical evidence of our alternative because P hat equals 0.12, which is more than 0.07. All right, we conduct a significance test. P-value of 0.025 is found. What does that mean? Assuming the null is true, there's a 0.025 probability of getting P hat of 0.12 or greater purely by chance. Now, do we reject the null or fail to reject it here? Because 0.025 is less than 0.05, we reject the null. And then in real life, what that means is Rockford should be switching to bottled water. Now, let's suppose that decision's incorrect. What could be a consequence? That they spend a lot of money on bottled water when they didn't need to because the water is actually safe. Since we are rejecting the null, we're saying that the water is unsafe. But we find out later that's an incorrect decision because the water was safe. This is what we call a type 1 error, where the null is true, but we reject the null. That makes us sad. Okay, and then we see if the water is safe, what's the probability this error will occur? It's 5%. In fact, this is one of those facts here that the probability of a type 1 error occurring is the alpha value, whatever your alpha value is. Okay, now let's do a different sample, and a different sample yields a p-value of 0.217. Do we reject the null or fail to reject it there? We would fail to reject it in this case because that 0.217 is greater than 0.05. And that would lead us to believe that we should keep the current water. In other words, we're thinking the water's safe. Now, this decision, let's suppose it's incorrect, what would be a consequence of this error? That the water's actually unsafe, so people could get sick or die from drinking it. This is what a type 2 error is. Now, our type 2 error is where our alternative is true, but we fail to reject the null. So when we look at like real world, which one would be more serious? It would be number 4 here. I hope we could all agree the health of people is more important than money. They both wouldn't be great decision making, but I'd rather, keep my people healthy than care about money there. That's just a real world decision making process there. But what's important here is when you look at this table, I don't necessarily memorize it, but at the end of the day, it is a tool to help you make these decisions. So when we're looking at it here, again, if we reject the null and the null is true, that's a type 1 error. Again, your probability of type 1 occurring is your alpha value. And like I said, in words, we say that the null hypothesis is true, but we find convincing evidence for the alternative. That would be a type 1 error. Type 2 error is where our alternative is true, but we fail to reject the null. The alternative hypothesis is true, but we don't find convincing evidence for the alternative. That would be a type 2 error. I've given you guys just on the key what the wording is for your alternative and your null hypothesis on the check your understanding to describe, so you can describe the errors made here. But again, just a quick overview of this lesson here. We'll see you in the next one.